So my name is Manish Yashvant. I'm in our partner development and partner success team at ThingWorx, which is a division of PTC, which is a global software company that some of you might have heard of, $1.5 billion business, if you will. So what I'm going to talk about is what ThingWorx is as an IoT platform and how it can enable solution developers, OEMs, and SIs to put together these IoT solutions in the market really quickly. If you look at what some of the analysts are saying and some of the press is talking about, there's billions of devices that are going to be connected to some sort of computing infrastructure or the internet in our lifetimes. To really get value out of these billions of devices, you need millions of new applications that don't exist today. These are not going to come from Microsoft and Oracle and so on. So somebody has to create really new, lots and lots of applications. And so that's the problem we went to tackle with ThingWorx. There are other people in the ecosystem, like we saw Monet and others focused on the connectivity side. How do we get lots of devices connected? And there's cloud providers where we're focused on how do we store all this data. But really, we focused on the application problem, if you will. And I'll say this in the context of one of our customers. And one of the startups I worked with in the last few months is a company called Eliminator. They're based in Southern California. So they came up with this new innovative fire extinguisher. And turns out that it's not the initial sale of these units itself that is quite expensive to a corporation. Any company, whether it's a small office like a dentist's office or a Walmart distribution center has thousands of these things and all their on their walls. And they not only have to buy them, but they have to service them every 30, 60 days. So it's an ongoing cost and an infrastructure and service, if you will. So this company came up with some new innovative way to reduce that service impact, and some of it can be done remotely and by the customer themselves. So they're trying to revolutionize that particular business. So when they wanted to go to market, they wanted to offer it as a truly smart, connected thing. And that's how we started to talk to them. Before we got engaged with them, when they looked at what it takes to put together a real, robust IoT solution, these are some of the things they have to deal with. Connectivity, what protocols do we use? Is it Zigbee or Bluetooth? How do we penetrate through walls and so on? How do we deal with security and privacy and provisioning and device management and all sorts of things that you have to take care of. So it's not an easy problem to solve. If you're a developer, if you invented the next new thing, or if you're an existing operator of a whole bunch of equipment, whether it's vending machines or chillers, if you want to create a solution, there's a lot to take care of. So it's quite a challenging problem. And that's really what we set out to solve with ThingWorx. So ThingWorx was a startup out of Pennsylvania, and we went live with their first product in 2009 or 10 or so, and PTC acquired them, and we've added other technologies into ThingWorx and really strengthened that into what we believe is the industry's leading IoT platform out there. And it's well adopted. We have 600 customers. And since PTC's heritage came from the industrial side of things, so a lot of our customers are from the blue chip industrial companies, GE being one of our best customers there, Caterpillar, Toshiba, and companies like that. And slowly you're starting to see a shift in other industries, whether it's retail or agriculture or smart home, cities, that sort of thing. So we're seeing a lot more adoption in the other areas. If you net it out, these are the capabilities or services that the platform offers. It is a technology platform on which our customers, our developer community, it could be a one or two man shop, it could be an SI like a boutique services company, or it could be a big global SI like Deloitte or Accenture, or it could be a OEM, a Caterpillar who wants to make their products smart and connected. And so lots of different kinds of models, if you will. But they have the building blocks to create a robust IoT solution faster. So the 5 pillars of capabilities we offer really start with connectivity. So we have different technologies to connect to greenfield things, newer things that have newer chipsets and connectivity, or a lot of brownfield things. When you talk about smart city, nobody's building new cities from scratch. I don't see that happening near time. But if you look at a city, there's sewer systems, there's drains, there's parking lots, all sorts of things that have existing equipment and PLCs and SCADA systems that you need to interface with. So you need capability to plug into those kind of infrastructure. So we got a couple of options in the connectivity. Then once you get to all of the data, you need to analyze the data. So we've got some basic alerts and alarms and event processing and if then else kind of rules that you can manage within the platform, but also some advanced capability in terms of machine learning. Can the machine learn from the large volume of data and figure out its own rules, if you will? What is a normal running pattern for this pump system? And then can it tell me when it starts to sound abnormal? We as humans know when a belt is slipping. You can hear it, you can sort of feel it. But can a machine figure that out automatically for you? So those are some of the things we are offering that for you. Then there's the development tools to help you create these applications, whether it's for the web or for the mobile device. And then some of the newer things is around experiencing this data in a whole new way. Can we put the machine data, the sensor data, on the thing itself, like a heads-up display in a car? If you look at the problem you face with the millennials getting into the workforce, we heard this from Caterpillar. When we hire a service tech, we give them, binders full of manuals, and they want to read it. They say, "Don't you have YouTube videos I can watch and learn how to fix these tractors?" So that's what they want. So how do we get just-in-time information on the machine itself? When I'm looking at a tractor, I'm looking at a sub-assembly. Can I get augmented data to help me, repair, service that particular broken system? So those are some of the things we're adding to the table. And then it is a platform. That means we don't actually offer the end solution. We're looking for you guys to help finish the solution. So we have an ecosystem and a marketplace for you guys to contribute and sell your components to the customer base ultimately. So that's the platform. I'll dive into each of them in a little bit more detail. But we do have a booth outside, and if you guys want to look at some demos and so on, feel free to stop by and we can dig deeper. So the first pillar is connectivity. So we've got a bunch of capabilities there. So one of them is agent technology that you embed in the thing itself, whether it's a washing machine or a toaster or a jet engine or whatever the case may be. This typically happens when you're building the thing yourself. If you're a device manufacturer, you have control over the embedded system, then that's an option for you. If you're an operator, like a city or a fleet transport system, you don't really have the ability to add new software to those things. You got to use what's given to you. So in those cases, you might need protocol adapters. Can you translate the language that that thing is speaking? And there's hundreds and hundreds of these protocols out there. There's no real standard emerging, in the near term. So we've got some technology that we recently acquired, a company called Kepware that gave us 200 different protocols in typical industrial and machine settings. So we can talk to Allen Bradley, Siemens, and Rockwell, and all sorts of PLCs and SCADA systems and historians and whatnot. So that's how you would connect to these brownfield data sources, if you will. We have our own device cloud. A device cloud is basically a database in a cloud. You're aggregating all this data, storing it, you have some APIs around it. But there's lots of other third-party clouds out there. Amazon's got one, and Azure's got one, and even device manufacturers actually offer some data in the cloud. So Rainbird, they make not only your home irrigation system, they also do industrial, for the agriculture space. They make weather stations and so on. So you typically install them in big fields. The data is collected over some sort of uplink, Verizon or whatnot, into a database in the cloud, and they give you a login or some APIs to access to that. So it turns out a lot of the source of data is really not from the device. Many of them actually moved it up one level up to a cloud, so you need to tap into those clouds. So we do that quite well. And then there's APIs as well if you want to integrate with that. So connectivity, we want to offer a very broad capability to integrate all sorts of data sources. That's what you'll find with ThingWorx. And we have partners in this area too, so we rely on a lot of partners to integrate their equipment and their data sources into the platform to provide to our joint customers. And as I said, there's different ways. There's no one model that works in every situation. Smart homes versus factories versus cities versus fleet telematics. There's different models. You can directly connect to the thing. It could be through a gateway. It could be tethered. more and more you see smartphones acting as a gateway. I got a Samsung washing machine at home. It has a Bluetooth connectivity. It doesn't always talk to the cloud. It doesn't tell me when it's running and so on. But it's really meant for service. If it breaks down, instead of me figuring out what the error code is and thumbing through a manual, it talks to an app on the phone and tells me in plain English what's wrong. And if I do call the 800 number, transmit that data so that they can actually have a way to look at what's wrong and help me fix it remotely if it's possible. So those are some of the ways that you will see these things integrated into the cloud. And there's lots of different protocols. There's some standards emerging in different industries. So in a factory or in an industrial setting, it's Modbus and OPC. In automotive, it's CAN bus. In home, it's Zigbee and Z-Wave. If you're dealing with wearables, it's NFC and Bluetooth. So there are some, but within each industry. But as a platform provider, we have to offer pretty much of everything. So you guys, as a developer, have the choice of how you want to deploy your solution. Here's an example. Electa, this is one of our customers in the UK. They make this oncology systems, big, expensive systems they can't afford for them to go down. It costs their customers money. And more they're selling in third world countries like India and Africa and China and so on. They can't afford to have service techs fly over and service them every time they're down. So they rely a lot on remote service, remote diagnostics, as much as possible before they need to take care of any catastrophic service event. So this is an example of a customer who's actually connected their devices. This is a big device, if you will, a big thing, but we also see examples of smaller and more volume things as well in our ecosystem. And for them, not only security was important, but privacy was important. FDA regulations, they have HIPAA compliance rules, so they have to separate the patient data from the machine data and channel the data into different paths, if you will. So that's part of what you get with the ThingWorx technology. We will do that. The next pillar is building applications. So what we have is a codeless environment. So it's really built for the average developer. It's not, you don't need to have a high-end Java or a cloud or architect and so on to build a robust solution. So we're trying to make it more democratic. We want to make the common developer to be able to build a strong solution. So we give you an IDE, a development environment. It runs in a browser to be able to model your application. So the way it works is you model the assets the way you look at your assets. You define a vending machine as a thing, and you define templates, you define the properties and the services and the behavior and the relationship. All that's done in a drag and drop modeling environment without writing a single line of code. So it could even be built by a business analyst, somebody who's looking at the requirements from his customer and defining it as a model. And it's easy to iterate and update the model as your requirements change. And the other part of the development environment is the UI development. So we have a tool called the Mashup Builder, lets you build web applications and mobile applications really quickly. Again, drag and drop, bind it to the model and the data sources, and then being able to generate the application itself. We can show you a demonstration at the booth or maybe a separate time. And there's some videos as well on our website, I think. This is an example of a customer. This is in California, in the Central Valley. It's a company called On Farm. They knew the farming industry well, so they've been acting as a service provider and a consultant to growers, and they created a solution. So they saw growers, ranch owners, farm owners, they have to deal with different points of automation. Rainbird had a system that you install one in each field, and they have a website you got to log into. And then the irrigation system had their own website. The water system had their own thing. The weather system. So they had 12 different places to log in and take notes and make decisions on when to water, when to irrigate, when to fertilize, how much acidity level, all that sort of thing. So it's a pretty high-tech business, if you will, this ag business. So they built this solution a few years ago on ThingWorx. These are some of the screens you can see here. So they have 500 farms in 32 states online, and they collect 50 million data points a month and manage in our application. So pretty cool little application. Again, we can demonstrate this to you guys at a later point. So that's the two pillars, connect, build. The third thing is analyze. Once you start collecting data, so you really need to be a little bit mature, maybe have a 6 months, years worth of data before you really start, taking the next step function, if you will, in trying to provide value from your solution. So you can analyze the solution for, some predictive capabilities. Can I predict when the machine is going to fail, when this pump is going to fail? Can I do preventative maintenance? Those sort of use cases. So we've got some capabilities there, from anomaly detection to predictive modeling to automated learning. All that capabilities is part of the platform. The way it works is, today, if you look at analytics, you need data scientists who know the domain pretty well. They need to know mathematical modeling. They need programming skills. It's a hard set of skills to come by, and then you need lots of these people. And IoT is actually making the problem worse. Because as sensors get cheaper, as storage gets cheaper, the volume of data that companies are aggregating is just overwhelming. How many ever data scientists you might have on your payroll. So what we did, this was another technology we acquired. This company focused on automating that whole learning. We don't necessarily do it better than the human scientists. We certainly do it much, much faster. So in the tool is all the typical algorithms that these scientists use, k-means and random forest and all the sort of algorithms that people use. But as a developer, you do not need to know any of that. You can point the engine at a data source. If you're collecting data, in industrial application, you might already have that. If you're sitting on a data historian from OSI Soft or GE or something, you have tons of very structured data. If not, as you build out your IoT solution, you start to get some new data you're harvesting the ThingWorx. But the tool automatically learns from the data, figures out patterns in the data for a certain outcome, whether the outcome is a failure condition or you want to maximize your revenue, whatever the condition is, you got to set that in the rule, and it creates a hybrid model. The way it works is it actually runs the data through all the different algorithms and figures out the best combination. So it creates an ensemble model. And then you test that model on some holdback data to see if it actually predicts what actually happened in the past. And you do that in a repetitive manner till you get the model accuracy up. Then you point it to some new incoming data. That's when it starts to predict what's wrong. So let me give you a quick demo. In this app we built, ThingWorx, there's a bunch of pay stations in San Francisco. We pointed about 50 different properties, not only from the machine itself, from service history and the weather, where it is, whether it's indoors or outdoors, all that sort of thing into the learning tool. And it predicts which machines are a high risk of failure and which ones are very high risk of failure in the next 1 month. So these haven't failed. So the old model, you wait till it breaks and somebody calls you and you send out a truck and go fix it. But during that time, you're losing customers and revenue in many cases. They're not collecting money if it's a vending machine or ATM machine or whatnot. So here, it tells you which ones are higher risk of failure, and you can ask why. Why is it predicting? It tells you the properties it figures out as a higher probability of failure. In this case, machine age. And also tells you which subsystem, whether it's keypad or the printer. And it looked at tons of data and made this prediction. So as you're running your service force, routing them and doing these jobs, you can spend some of their time in going after these preventative maintenance issues so that you can reduce your total costs and operation costs and customer stats and so on. So as it gets down in the demo, it shows you some more details about why it's predicting this failure. Here it tells you the machine attributes, the maintenance attributes, the weather, location. These are all the things we threw at it, and it figures out which of those matter, which ones are not significant. It's just like, elections and all these, everybody's got data science trying to figure out which ones matter, which don't. It's the same thing, but it just does it faster. In this case, it tells you the machine age was a significant contributor to that failure. For some reason, the newer models, the 6 months or newer, had more failures than some of the older ones, which are more stable. So some bug introduced in the new models. So it tells you some other factors that you can consider. It's also great for engineering, so they can take out these bugs and fix the issues in the next version of that product. So that's analytics. And then the next pillar is around experiencing the data in a whole different way. I mean, it's very common today to present machine and sensor data on dashboards, whether it's on a web page or a mobile device. What we're trying to do is take it to the next level. Can we put it on the thing itself as you're looking at the thing or interacting with the thing? And that's what we've done with this technology. We acquired another piece of technology from Qualcomm, in this case, called Vuforia. But there's two things going on in the industry. One is virtual reality, which Facebook and Google, after that's a lot about gaming and retail experience, sales and marketing kind of experience. What we believe is that augmented reality has some applications in the commercial and industrial space. Again, going back to the capital example, can I give my service tech just enough information to fix this particular problem as he's looking at the machine? When I'm up on a tower trying to fix a wind turbine, I need both my hands. I can't have one hand looking at a tablet and instructions and so on. How can I present that information? So these are some of the new applications we're driving. So in this case, you'll see this demo here. This is a blue pump. This could be part of a big rig, if you will. Just for demo's sake, we put it on a table, just the component. We're now looking at it through a special app called a Thing browser. Just like a web browser, there's a Thing browser. Now, we're augmenting reality with some digital information. So some other pieces, if you will, around that with it. You can see this demo live outside. We've got one of our guys with this same pump, and you can play with it if you want. So now you got digital interface there. Click on each of these buttons to tell you different things. Product information. Maybe it came from a PDM or a ERP system. You might next it's going to show you operational information. What's the flows and alerts and vibrations and service events. All that stuff is jumping out at me. So if I'm walking down a factory floor, or I'm looking at my heating systems and chillers or whatnot in any commercial situation, just through an app, it's going to tell me what's wrong with it right at that point, if you will. And then in this case, another button tells me my service instruction, how to assemble, disassemble, or replace or repair this particular thing. So it's really left to the developer's imagination what you want to do with this technology. We're giving you, again, the Lego blocks. We think there's lots of applications for this out there. You see this today in sort of consumer space. IKEA has an app where you can scan a product of their catalog with an app and point it at your living room. It shows you how the sofa is going to look in your house. That sort of thing, but we are just taking it to the commercial world. Here's another fun example. There's a generator behind our office building in Boston. When you walk up to it, you don't know what's going on. You don't know anything about it. But now if I look at it through an app on my tablet, in this case, I've got X-ray vision. So it's like, Superman vision. I can look through it. I can see serial number, make, model, last service date. I got the alert jumping out at me. The analytics engine is predicting failure in the shaft in the next 3 months. I've got some service events. Again, stuff that I could go back to my office and look at, report someday. But while I'm in the floor, I'm interacting with the thing, I can get real-time information that's sitting in an IoT system. So that's one of the things we're bringing to the table. We got a lot of interest from, right now, commercial companies, Caterpillar, Airbus and companies like that. I think they'll start to trickle down to the small and medium business too. So again, the thing is, everything you're showing you here does not require a program. You can build this app with that similar drag and drop and assemble, functionality that I talked about. Then finally, because it's an ecosystem, we rely on the ecosystem because it's a platform, we really rely on the ecosystem to build upon it. We don't really offer everything too. We've got most of it from the connectivity to device management, application development, and so on, but we still rely on other pieces, if you will, from our partners. Our hardware, of course, is one big thing. We need domain expertise, so that's where the SIs come in. We don't know agriculture, we don't know insurance. But there's lots of use cases out there. So we're looking for partners to go take solutions to the market, build on top of our platform. So we're fostering developers. We have 200,000 developers on our platform today, and we also have a dev zone. These are our different categories of partners. Lots of them on the hardware side of things, whether it's Monet, who was presented earlier today, or others. who make things from chips to boards to embedded software to device clouds and the like. We got telcos who can take data from point A to point B, whether it's satellite or 3G, 4G, LTE, you name it. We have SIs who can put together the whole solution. We have software partners who want to participate in the whole ecosystem. Because you might have sensor data, machine data from the thing, but you have contextual data sitting in business systems like Salesforce and SAP. Who's the owner of the thing? What's their warranty entitlements? What's their service record? All that's sitting in a packaged application. So you need to be able to bring them together too. So that's what we offer with this sort of ecosystem. And we have a marketplace where you can offer, the partners can offer their wares, if you will. And then finally, I'll end with this. For universities, we have an academic program. We are offering free software tutorials to educators, to students. So if there's anybody interested in here, I think in Utah as well, we've got a couple of universities participating in this program. They have access to this technology to run hackathons and use in their curriculum so that they can come out to the industry with some experience. That's it. I will stop there.
All right, thank you. Do we have any quick questions for Manish about PTC ThingWorx? Go ahead.
So you guys are kind of positioning yourselves as like Microsoft, the Microsoft of this industry. Do you know about any Linux, anything that would be like the Linux to your Microsoft?
You mean the open source version? I'm sure there will be. Ours, we are offering a developer toolkit, if you will, for you to build an application. Because as I said, there is going to be a lot of moving parts. As I said, you can build it on open source, but there's also going to be a challenge around how to get to market faster. So that's what we are offering with our solution. And at the same time, we're making it open enough that the ecosystem partners can add on to it, whether it's an integration to a mapping technology from S3, or if it's a telco integration or a business system integration. Those are all the areas where partners can add to it.